Hi everyone, my name is Dorian Crutcher. Thank you for coming and watching to this simple NFT minting tutorial. Who am I? I'm Dorian Crutcher from the Near Dev Rel team. I'm also the host of our Blockheads web series, and also I love to play rugby. And I currently play kickball in San Francisco. So if you're ever in SF, say hi. So what we're doing today, we're going to be doing a mini dive into the minting section of our NFT Zero to Hero tutorial made by our very own Benji from the Near Dev Rel team. And you can find it here at this link if you guys are interested in diving deep for yourself. It's really cool, really well planned out, really detailed. So definitely encourage you guys to check that out. We're also going to be doing a small example of implementing Near API.js to wire up a smart contract to a front-end JavaScript application. The tools we need for this tutorial will be Yarn Package Manager, Near API.js, Near CLI, download onto your terminal, and an account on the Near testnet wallet. So go to wallet.testnet.near.org to make your testnet wallet account to interact with the blockchain and your application. And an ID such as VS Code. So that's what we're going to be using in this tutorial. So get that all downloaded for yourselves. So to start this off, we have two repos we're going to be using. The NFT tutorial repo, which is where the contract code exists, and the NFT simple front end I created, which just includes a button that will allow us to mint our NFT onto our account and have our NFT appear in your wallet. So I'm going to exit this and clone these two repos right now. So under my little face, git clone. Git clone, there we go. Okay, so now we're cloning the repos. Okay, awesome. So we're going to go ahead and enter our NFT tutorial folder. And after we do that, we're actually going to check out this branch called to.minting. So if we go back to this link here, you'll see that this NFT tutorial is rather in-depth, and it's broken up into multiple sections. But each of these sections have their own branch in our NFT repo that leads to a partially complete smart contract. This to.minting is going to be all the code we need to mint an NFT onto the Near blockchain and have it appear in our wallet. You can go into the tutorial to see the full in-depth tutorial to see how you build out this NFT smart contract for yourself. But for now, again, we're just going to use a partial contract, enough of the tools to be there for us to mint this NFT. So let's go ahead and check out this to.minting branch. So git checkout to.minting. Hit plus there. Oops. Okay, so if you can see under my little face here, I'm going to make my face a little smaller. You can see to.minting here, knowing that we're in that branch. And yeah, let's continue forward. So first things first, what does it mean to mint an NFT? What does it mean in terms of a smart contract? To mint an NFT, a contract needs to be able to keep track of tokens, store information for each token, i.e. the metadata for each token, link a token to an owner as the final step. So let's take a look at the contract struct. So we can go to lib.rs inside of our NFT folder, inside of NFT contract, inside of source, and we find lib.rs. And this is where this contract struct actually exists. Right around here. So this is where we're going to define, so in this contract struct, we have different fields, and each of these fields contain what's called a collection. A collection is just a data structure that Near has to simulate things like maps, unordered maps, or vectors. So here we have two lookup maps, which just accept a key value pair for any data you want to store onto the Near blockchain. So this first one here is just an owner ID, which accepts an account ID. An account ID is just the type. It's just the custom type that Near has created and stored in their SDK. All it is a string that ensures that there are no special or unsupported characters used in that entry. We have tokens per owner, which allows you to keep track of the tokens owned by any account. Tokens by ID, which returns all the information of a specific token. And tokens metadata by ID, which returns the metadata for a specific token, so just the metadata for that specific token. We also have this other type here called token ID, which is just a string. So if I were to put string there, that would also work. Again, we're going to reference this this struct later on in the tutorial. So I just wanted to point that out early on and know, so you guys know what's here and you guys also know where the token information gets stored. So next up are our initialization functions. So what is an initialization function? So all it is a function that can only be called one time. If you try to call this function again after you call it once, it'll just throw an error saying that the contract has already been initialized. So typically what's done is after the contract gets deployed onto an account, so every contract code gets deployed onto a new account, you'll call this function to initialize the contract, or to initialize some data that you may want to like enter into your contract before actually using it. So here we have two initialization functions marked by these initialization flags, I think macros. So the first one is the new method, which initializes all the contract fields defined above. So all these fields that we defined here gets initialized in this new method here. After that, we have our new default metadata, or new default meta method, which initializes the contract metadata. So that's all this information right here. So now what is exactly this information? So if we head over to our metadata.rs section, you can see we have this field called NFT contract metadata. We have 3 required fields, which is the only ones I'm going to be explaining for now. You can look into these other ones on your own. This contract is available for download, and the comments are very detailed in this in each of these contracts. But so the spec is just a version of the smart contract. So we can update this as we modify and upgrade the smart contract. Upgrading smart contracts is also included in the NFT 0 to hero tutorial, by the way. We have the actual name of the smart contract. We have a symbol for the shorthand of the name of the smart contract. So in this case, the name of the smart contract is NFT tutorial contract, and the symbol is just Go Team. It could be any shorthand version of the name that you create or just a nickname. It's called Go Team because we're going to be minting a Go Team token today. That's the NFT we're going to actually be minting and seeing in our near wallet later on in the tutorial. So next up is we have our token metadata. So back to metadata.rs. So we're going to get rid of that. I'll get rid of this. There we go. It's a little bigger. So now this has a bunch of different fields you can populate. But the only ones we're going to be paying attention to for now, and for the sake of this tutorial, will be the title, description, and media. So the title will be the actual literal name of the NFT. And the description will be a description of the NFT. And the media will be the information that the NFT actually contains and references. For example, it could be an image. It could be a storage link. It could be whatever you want. For this tutorial, we're going to be using a GIF. So in other words, an image file. If you go to nomicon.io, this is a very useful website because this is essentially where all the information about NEAR's token standards lives. So you can see information about our non-fungible token standards. You can see information about our fungible token standards. You go here and you follow what's in this guide essentially, and that's going to adhere your contract to our token standards. Again, you can adhere to our contract standards using the 0 to hero tutorial that I'm going to keep plugging throughout this entire video. But yeah, you follow that tutorial, you're going to be following our standards essentially. Yeah, so again, nomicon.io to get detailed information on the NEAR, NFT, and fungible token standards. So continuing on. Now we're going to actually look at the literal minting function itself. And then we're going to get our hands dirty soon to actually see these like functions in action. So hold tight. So in mint.rs, so now we're in mint.rs, we can see our NFT minting function. Our NFT minting function will interact with these 3 fields that were defined earlier in our struct. So again, remember we pointed out that struct. We're referencing that a lot because that's going to be where NFT information is stored and tracked. So we have tokens per owner, tokens by ID, and tokens metadata by ID. So how does the minting function actually interact with these different fields? Well, for the tokens per owner field, it adds the token ID to a set of tokens that the receiver then owns. For the tokens by ID field, it creates a token object and maps the token ID to that token object in the tokens by ID field. The token metadata by ID maps the token ID to its metadata. Okay. The arguments listed here will be the token ID, which is a custom ID given to a token. That's just simply a string. So again, we defined it a little bit earlier. The metadata itself, which is just an object, so metadata associated with the token. then the receiver ID, which is the account that will own the NFT. So again, this is using this custom type, which is a string that omits special characters. In other words, it'll just be everything that follows in your account, essentially, in your account name, essentially. For the actual minting function itself, I'm going to minimize this a bit so you can see this a little better. So this first line here takes into account or stores the initial storage that the NFT contract is currently using. And I'm going to get into more detail why we have to actually care about storage in a minute. It's fairly important, but we're going to get into that in just a second. So this next field is where we're going to track the owner of an ID, or an owner of an NFT. So we're storing the receiver ID, which is just a string, into this token object here. After that, we have this assertion field. This just checks if the NFT that we're minting right now currently exists. If it does, it will throw this error saying this token already exists and prevent the minting of that token. After that, we have one of our struct property. We have one of our struct fields where we actually insert the metadata for the token. So we can see the metadata here is being stored to the key, which is the token ID here. After that, we have this internal function. So we have this whole slew of internal functions here. It's actually not too bad, but we're not going to go into details of what each of these are. It's a little past what we have allotted for time. But if you go again to our NFT 0 to Hero tutorial, it'll cover all the internal functions for you, and you can get a better idea of what each of these do and how it all works. So again, go check out the NFT 0 to Hero tutorial at near.org for more information. But for now, the high-level idea is that this just adds the token to the owner. So here's the actual literal token ID to the owner ID. That's all you should really need to know for now. And then now again, we're back to storage. So again, why do we even care about storage? It's because every contract that is created on Near is deployed onto a Near account. And every bit of information that gets stored onto that state of that contract has to be paid for in some way. It's being paid for by that Near account. So the more NFTs minted means the more storage used on behalf of that account means that more tokens have to be paid out in order to cover storage. This is called storage staking. You can find more information on that in the Near docs under storage staking or under storage. So the more storage you use, the more the Near account has to put up in tokens to pay and cover that storage. So what we're doing instead is we're charging the user for that storage, or we're having the user pay for that increased storage or for that minted token. And this is done to prevent someone spamming the mint function onto an account and draining their entire account of all their funds, because that would be, that would not be good. So in this case, the user itself has to pay for every NFT they're storing, and any excess funds that they pay for gets refunded using this function here. It's one of our other internal functions. Okay, so now let's jump into deploying our smart contract onto a Near account. So first thing we do is run yarn on yarn build. Yarn is going to install our dependencies that come with the Near tutorial repo. So we're going to run yarn. And yarn build will run a script to compile our smart contract. That compiled smart contract will be turned into a .wasm file, which according to this build.sh script will appear in a file called out. We actually did compile it earlier, but we're going to compile again just for tutorial purposes. So yarn build. You can ignore all these ignore all these warnings when you see them. Again, this is a partial contract, so the full contract through the 0 to Hero tutorial will finish and result in none of these actually appearing. We're using a partial contract, so that's where you're seeing all these warnings, so don't worry about that. So over here you can see our main.wasm file. So let's just keep moving forward. So now we're going to actually have to create our Near account. So let's head on over to wallet.testnet.near.org, and let's make a new account. So we're going to create an account. Just call it anything you want. You can call it whatever name you want to give it. Let's just call this ETH Denver NFT Near.testnet. I think that's fine. I'm going to copy this so I don't have to retype this later on and reserve that account ID. It's going to make a passphrase for me, so I'm going to hit continue. And I'm going to copy this. There we go. Oops. Oh, okay, it's fine. And hit continue again, and hit get word number 4. We're Word number 4 is rescue. So we're going to type in rescue here. Rescue. Let's give it 1 minute. Just waiting. It may take a minute on your end, so just be patient. Okay, so there we go. We have our new account name. We have a new wallet name. So we're gonna again just copy this over, so we don't have to retype this, and log in using near CLI. So now when we run near login, that stores a full access key pair onto your local machine for near CLI to use. So we're going to run near login. We're going to give this account, we're going to give full access to near CLI via this account. So that's what's requesting here. So we're going to paste in our name, type in .testnet, hit confirm. So once that's complete, you'll see this window, and you can just close this window. You should see a little message prompt here saying logged in successfully. So that's how you know it worked. Moving on with our demo, we're actually going to store that account name we just created into this variable here for our CLI. So we're going to say export. I'm going to make this a little bigger and move this window to the side. Get rid of that. Export. NFT contract ID. Don't remember to add the .testnet. And we're going to echo this to make sure this works. So echo $NFT contract ID. And we should see under my little face here the name of our account. So that's awesome. So we know that works. So now we're going to locate we're going to find the location of our .wasm file. Again, that's just the main .wasm file, and we're going to then use that to deploy. We're going to use that to deploy this wasm file to our account. So we're going to say near deploy --wasm file file out /main .wasm --account ID $NFT contract ID. So before I hit enter, let's just kind of break this down and see what I just did. So near deploy, near comes from the near CLI. Deploy is the function used to actually deploy WASM files onto an account. This --wasm file option specifies the WASM file to be deployed onto an account. So this is the actual WASM file itself. --account ID is the name of the account on near that the WASM file will be deployed onto. So we're going to hit enter. Starting deployment. See your name here, ETH Denver NFT near.testnet. And it says done deploying. So there you go. We have our WASM file deployed onto an account. So remember, next thing we do right after we deploy our smart contract onto an account is initialize the contract using the initialization functions. So here we have, I'm going to make this a little bigger so you guys can pause the screen and see. We have near call NFT contract ID, new default metadata. That's the initialization function that I described earlier. Owner ID, the owner of the contract, which is just going to be the name of the contract account itself. So this owner ID is the name of the contract account itself that we're passing into this method. And then anytime we call a contract, we have to specify the account that is making this call. So this technically doesn't have to be NFT contract ID, but for now, for this example, we're just going to use a contract account to make a call to itself to initialize this function. So we're calling the function itself from its own contract. So we're going to copy literally all of this. Oops. And just paste into our terminal. So I just have to wait for this to succeed. timeout error, so let's try this one more time. Okay, so it seems like the contract has been initialized. Just gonna double check on the wallet itself. Okay, so we can see that the initialization function succeeded, and we can test this out using a view call, which is what we're gonna do next, to see if the token metadata has been properly stored. So remember, that initialization function that we just called earlier, what that does is store the contract metadata onto the contract itself, into that state. So lib.rs, move my face back over here, and we can see all we're doing is storing this information onto the blockchain. So if I run near view, so the difference between call and view depends on whether or not the function is a change method or a view method. Change methods change the state of the blockchain, or change the state of the blockchain, change the state of your account. And view method just pulls information from that state. So if you ever need to view any information from that state, we just call a view method, and it doesn't cost anything. So we're going to paste this here. So there we go. We can actually see the NFT contract metadata. So we know that the initialization function worked. So that's a good thing. So let me just make this a little bigger again. Sorry, just kind of keep going back and forth between these two. So now this will be the literal NFT that we're going to mint through near CLI. After that, we're going to run our front end and show you how to wire up a front end so you can mint it from there too. But after we run this, we should actually see the NFT appear in our wallet. So that's going to be really exciting, really cool. So the function will end up looking like this. It looks kind of crazy here, this NFT mint, all this token object stuff. I'm going to essentially describe what this argument looks like in a cleaner format. So we have, let's make this a little bigger for you. We have the token ID. We can name this anything. For now, we're just going to name it token-1 for purposes of this tutorial. The metadata for the token, which we're going to be using the title, description, and media section, and then the receiver ID, meaning the owner of this token, which will just be the NFT contract ID again, right? The contract we just created. But again, this could be any near account. So you can maybe gift someone an NFT if you want to via testnet. So we have title, which would be my non-fungible token. Description, the team most certainly goes. Again, this will be a Go team token. Then the media. So this link actually links to a GIF, which will be the NFT itself. And you'll see what I mean in just a second. So we're going to escape this. Actually, I'm going to talk about this. So this is what it will literally look like in your terminal when you call it. So you can pause the screen, take a read over this in a minute. The only thing I want to point out here is this -- amount 0.1 near. So this is how I attach near onto a call through the CLI. Remember, this near is being used to pay for storage after minting this NFT. So the cost of storage is going to be covered by the user. Again, this user is just a contract ID, but this can be anybody calling this account method. And that user will have to pay for storage to mint an NFT. So that's the only kind of part I want to describe here. But everything else I kind of described earlier. So I'll put that function down here. So we're going to paste this in there. So we're making a new call. If I go to my near wallet now, I shouldn't see anything in here. So this is an empty collections tab. If you see this empty string here, this is how you know this function call actually succeeded. It will let you know if a function call has failed. So this empty string is a good thing. But we can actually add some comments if you want to see some actual output. But so if I refresh the page, go back to the collections tab, or collectibles tab, we should see the Go Team token. So this is our NFT. This is the actual literal NFT we just minted. So this is how you actually mint an NFT with our contract using near CLI. So good job, guys. If you made it this far, you've just minted your first NFT. But now let's just see how we actually wire this all into a front end. So if I were to go back to, let's see, first I'm going to go back to my slides, make sure I didn't miss anything. We can even view information about our NFT, but you could just simply type in this command and you can get the information we just stored onto the blockchain about your NFT. So if you want to do that, you can go ahead. Okay, if you guys made this far in the tutorial, I want to say good job. You guys have minted your very first NFT using the Near CLI. Next up is how you actually use Near.js to wire up the contract to your front-end application, and where we're going to be minting another Go team token to this account. Again, it'll be wiring up a contract or showing you guys how to wire up Near.js so you can use a front-end application with the Near blockchain. So it'd be really cool. So bear with me, guys. It won't be too much longer. We're almost done. So very first thing we're going to do is going to get out of this repo here, this NFT tutorial repo. Go into the NFT tutorial front-end repo and switch and check out this branch called eth-denver-tutorial. So git checkout eth-denver-tutorial. After that, we're going to run yarn to install the dependencies for this application, and then yarn start to launch the application so you guys can see what we're working with. It's a very, very simple application. It's literally just a button that just mints another Go team token. So you should see 2 of these tokens appear here once we're done with this tutorial. So I'm going to first log in. When we log in, we're going to create a new function call access key for this application. On here, there's function call access keys, full access keys. Won't go into details of what those are about, but we'll have maybe a link in the description for you guys can check out so you can learn more about the difference between these 2 types of keys. Or key pairs, I should say. So if I hit mint NFT, that should create a little note here saying add a contract function call here, because we have to actually add the logic in, so you can show you guys like what that process looks like. It's pretty straightforward. Before we do that, I'm going to actually run through this entire architecture. It won't be too long to show you guys what this is all about, or to show you guys what the actual process of connecting your application to the Near blockchain looks like. Before I do, I want to make sure I mention this resource. It's very valuable. It makes this entire process a lot easier for any application you're setting up. You want to go to the Near API.js quick reference guide you can find on our docs page. If I click this link. I literally always go back to this page every time I make a new application because it's always just really handy. It's really clean. It's really easy to look through. You can see here how to install Near API.js, to import your account, to setting up your application on a front-end application or a Node.js script if we want to do some back-end work with connecting to the Near blockchain. So you can see how you can get your key stores using a browser, using a local directory. It's very, very handy. You can sign to your application, load an account, launch a contract, deploy an account. In fact, Near CLI is a wrapper around Near API.js. So this is also kind of a way that Near CLI works. But Near CLI has its own page. But anyway, so just want to point out this reference for you. Make sure you check it out whenever you're using Near API.js if you want something quick and easy to reference. So going on with the tutorial, we're going to start with our configuration page. So let's see, we're going to minimize all of this. I'm going to move my little face back down to here and go into our config.js file. So this is a template structure that I use to start our application. Typically, you can go to near.dev. We'll use one of the example applications that best fit your needs. That's your starting point for your application. That's what I would suggest. And if you have any questions on how to get a good quick start onto your application, you can always message me on our Discord channel. I'm just Dorian Pipe Near. But anyway, so in this configuration file, we're just going to look at one chunk of these things. So this file is just made so you can easily switch between these different types of configs. So one for testnet, one for mainnet, one for betanet, local, whatever you want. But typically, we're going to be using testnet, so it's just set to development while we're actually creating our application. So in this file, we find this object. It returns this field called, it has various fields called network ID, node URL, contract name, wallet URL, help URL, and export URL. This denotes the exact network you want to connect to, which is testnet. This links you to the actual node you'd be working with. So rpc.testnet.near.org is a node that we typically use during development. The contract name, meaning the contract account, that's going to be that the project will be deployed onto. That's actually defined in our actually up here. So I'm using a different account for this file. We don't have to use one that we created earlier. I'm just using one that this application was made for. Then we have wallet URL to connect to the wallet, and the helper URL to actually fund dev accounts as we create this application. So you can actually create dev accounts, which are just like randomly generated accounts by the Near ecosystem, funded with their own test tokens. And this is what is actually used to fund these test accounts with test tokens. And then the Explore URL. Explore URL is just how you explore or find information about transactions, information about accounts. You can find all this really cool information using our very own Explorer on Near. So yeah, and that's essentially what's happening for these other sections too. So just looking at one little chunk of that to understand it. Next up is I believe the utils folder. Yeah, so utils.js. So essentially what's happening here is we are retrieving the config output. So we're retrieving one of those objects that we just went over. We're using that to connect to the Near blockchain. We have a bunch of window properties listed here, defined here, just to expose these tools in a global setting. You may not want to do it this way, but for this application, that's just how this particular application is set up, just so I can access these a little bit easier. We can always reference these tools by importing Near API.js and just another JavaScript file. And then finally, it creates a new contract object. So this is the actual object that lets us interact with our smart contract. And the functions that we are going to use or expose to the account that's logged in will be the NFT mint function and this function I created called check token to check the existence of a token in one of those collections that I defined earlier. So, but the main one that we're going to be focusing on is this change method called NFT mint. So again, difference between change method and view method is that change methods modify the state of the blockchain, meaning that anytime we store information or change information on the blockchain, we're changing the state, which occurs a fee. So that's what change method does, just changes or adds information onto the blockchain. That's why we're putting the NFT mint function there, because we're adding information to the blockchain as we mint a new token. The view method is something we're retrieving from the blockchain. In this case, we're retrieving a Boolean from the blockchain. So we're just pulling information from the blockchain. So it's a free method. We're just retrieving this information using a view method. That's what's called a view method. Yeah, so again, these templates are laid out in Near Dev examples for you, so you don't have to memorize everything. And you can always go to the quick reference guide too, just to see how this all works again too. So yeah, now we have to actually just add our minting logic. So if we go to mintingtool.js, we can see, let's see. Yeah, you can see that little console log that I put there saying you have to add the contract function call here. So I'm gonna cheat a little bit. You can pause the screen there to see what I just added. But let's see, Control-C, paste over this console log, and pull this back up for you if you want to see it. There we go. So yeah, it's very similar to what we added in the actual CLI tool when we made that function call from the Near CLI. So we have our token ID here. It's a unique name that we're giving this token ID. So each of these token IDs will be unique. Essentially, that kind of check method that I showed you earlier in the view method. Sorry, that view method I showed you guys earlier checks for this token ID to see if this token already exists. I'm just kind of customizing it based off of the name of the account. So it'd be blockhead.testnet-go team token or Dorian.testnet-go team token. So each of these will be unique based off whoever's logged in. That's just the way I kind of set up for this example. The metadata consists of the title, description, and media. It's the same thing as before. And then the receiver ID will be set to the person that's currently logged in. If I go to utils.js, you can see window.account ID will just return the literal string of the person that's currently logged into your application. So if I go back here, go back to our application, go back to the mintingtool.js, hit save because I didn't save this. Also, just one more thing, all function calls make to your contract are asynchronous, so be sure to include this async function or async call to your method here, and add an await here to wait for the response of your function call. So again, all methods or all calls you make to a blockchain are always asynchronous, so keep that in mind. So now we've added that, I can just hit this mint button again. And what we should see, just reminder, you have one NFT here. If this works, we should see two NFT Go Team tokens here because I'm minting the same token just under a different token ID and under a different contract account ID. So it's requesting one Near for storage. I should also go into that a little bit. So this additional method here, this additional line here is an optional line you can add for gas. So I'm manually adding some amount of near to pay for the gas that may occur while using making this transaction. This second line here, this second argument afterwards, or I guess third argument I should say, is a deposit that I'm making. So that's just literally sending near to this contract account. So I'm using this to pay for storage of this newly minted NFT. So that's all it's doing. So the reason why there's so many zeros here is because this is the value set in Yocto near, which is 1 times 10 to the 24th. But this 1 times 10 to the 24th is equal to one single near token. So again, this is just simply called Yocto near. So 1 times 10 to the 24th. We're gonna hit approve. Once that completes, it should redirect us to the application. Okay, so I'm using that check method to check for the existence of this NFT according to whoever's logged in. If whoever logged in has already minted an NFT, this little message will appear, and I include this handy link to your Near wallet. So we can go to our collectibles tab. And there we go. We have two newly minted Go Team tokens, Go Team NFTs, to our Near wallet. And that's it, guys. That is our entire tutorial. Again, I encourage you guys to go check out the NFT Zero to Hero tutorial found in our near.org documentations page to get a full in-depth look at how to become how to become a hero on making your very own NFT smart contract. Thank you so much, guys, for watching, and I hope you had fun. Message me on Discord if you guys have any questions. And yeah, have a good day.